Welcome to solverfy.
The problem given to us is about maximizing a function z equals 10x1 plus 20x2, and this is subjected to some constraints which are as follows. The first constraint is minus x1 plus 2x2 is less than equal to 15. The next constraint is x1 plus x2 is less than equal to 12. The last constraint is 5x1 plus 3x2 is less than equal to 45. Also, the non-negative constraint is that x1 and x2 are greater than equal to 0. Let's give this inequalities and equation a name. Let's say 1, 2, 3, 4, and 5. We will use graphical method to solve this problem. So first of all, let's plot these constraints in the graph. In this graph, we will plot these inequality constraints. Let's do that one by one. So, according to the first constraint, we get this line. This is the equation of this line, which we have written as equation 2. And the region below this is the region required. Now, let's look at the second constraint. So, the second constraint is x1 plus x2 is less than equal to 12, which will give us this equation and this line. And this arrows shows the direction according to the constraint, that the region below this line are the region required. Now let's move to the third constraint. So this is the third line which we got from the last constraint or equation 4, and this is the equation of this line. Also, we have two non-negativity constraints, that x1 and x2 are positive. That means we have this part, shaded part, as the feasible region. So we have to find that at which point we have the maximum value inside this feasible region. Here we can see that at this point three lines are intersecting. So let's draw the bigger version of this portion to visualize it clearly. After zooming in, we can clearly see that these two lines are intersecting at this point, and these two lines are intersecting at this point, and the third intersection is outside the visible region. So we will have to consider only on these 2 points. Let's see how many corner points do we have in this region. We have already spotted these 2 corner points. Let's say this is first, this one is the second corner point, and we have the third corner point here, and the origin is the fourth corner point, and at the end we have the fifth corner point here. Now we will have to find the value of objective function at these corner points and obtain maximum of those values. From the figure, we already know that the point 4 is at origin, which is at 0, 0. The point 5 is at 9, 0, and point 3 is at 0, 7.5. And to find the values of point 1 and 2, we will have to solve the equations of those lines intersecting at those points. Point 1 is at the intersection of equations x1 plus x2 equals 12 and 5x1 plus 3x2 equals 45. This will give the point 1 as 4.5 and 7.5, and the point 2 is at intersection of equations x1 plus x2 equals 12 and minus x1 plus 2x2 equals 50. This will give us the intersection or point 2 at 3, 9. Now let's create a table to find the values of the objective functions at these corner points. So the first column of the table will contain these corner points, and the second column will contain the objective function z equals 10x1 plus 20x2. The first corner point we have is 4.5, 7.5. The second corner point is 3, 9. Third corner point is 0, 7.5. The fourth corner point is 0, 0. And the fifth corner point is 9, 0. The corresponding objective values are 195, 210, 150, 0, and 90. From here we can clearly see that the maximum value of the objective function is 210. Therefore, we have the answer as the maximum value of objective function, which is z equals 210. This is our final answer. Hope you understood. Thank you.